Hey guys, so here's part 2 of the 8.6 notes. So we're going to do 2 examples here, identifying a quadrilateral. So basically we're going to see if is there enough information given in the diagram to show if the quadrilateral is something. So in this one, example 2, is enough information given in the diagram, so there, to show that quadrilateral DEFG is a kite. So we can only use the information provided on the shape here, or on the picture that we have. So we notice we have from DF and EG. What are these lines called? Well, these are our diagonals. Remember, the diagonals are lines that are inside the shape. Now notice here where these lines intersect, they create a 90-degree angle. Remember, what that means is the diagonals are perpendicular. Okay? So we're going to look at a kite to first make sure that is a property of a kite, and make sure that's really, we can't find that anywhere else on any of the quadrilaterals. So we look at our quadrilateral family tree, which you should have that with you. Notice that it does say diagonals are perpendicular. That is a property of a kite. But now let's look at some of the other quadrilaterals and their properties. In fact, if we actually go to rhombus, that also says diagonals are perpendicular. So we're only given this one piece of information. Can we automatically assume this is a kite? No. Okay, so there is not enough information given in the diagram. And the reason is because this could be a rhombus. Since those diagonals are also perpendicular. So I'll say, since it also has the property of diagonals being perpendicular. Okay, we're going to do another example just like this. We're going to go to this example 3 here. So once again, we're going to identify a quadrilateral. Now this one, we're going to figure out, is there enough information given in the diagram to show that ABCD is a rhombus? So let's look at all the information that we have, okay? So the thing I see is that I notice that once again, we have our diagonals, so I'm going to mark that red. And notice what it's doing to actually each of our angles. It looks like it's splitting them into 2 equal parts. Now, do you remember that word when we say it cuts into 2 equal parts or 2 halves? Bisects. So we actually can see that the diagonals, remember, they are lines that are inside the polygon. So in this case, we can indicate that the diagonals bisect a pair of opposite angles, which we can clearly see that. Okay, so now we are going to go ahead and figure out, when we are looking at this, okay, does anything else talk about diagonals bisecting a pair of opposite angles? Okay. So we see diagonals bisect each other, but that's not bisecting opposite angles, okay? Well, we look at everything else, nothing really says that diagonals bisect a pair of opposite angles. Now, another thing that we can illustrate with our angles is notice that A and C, they're definitely going to be congruent, because if we add them together, angle A is going to be 40 degrees, and angle C is going to be 40 degrees. That's going to be the same thing for B. We can definitely clearly see if we do 70 plus 70, that's going to be 140. And angle D is going to be the same thing. So they are both 140 degrees. So another indication of this being a rhombus is that both pairs of opposite angles are congruent. Okay? That is also a feature of a rhombus. Okay, so we can see that there are two properties that indicates that this is a rhombus. Now we can see that both pairs of opposite angles are true. That deals with parallelograms, but remember, all the properties from parallelograms, it goes down to rhombus. And we know that diagonals bisect a pair of opposite angles. That is the property solely for a rhombus. So we can definitely say, yes, there is enough information to indicate that this quadrilateral is a rhombus. So we just say yes. And then we have our 2 reasons there. Okay, make sure you guys watch part 3 of the 8.6 notes.